Students, let's look at this question here, which is on binomial distribution, I believe. So a bag contains of 4 red, 5 blue, and 6 green balls. They are distinguishable except for their colors. They are indistinguishable. Okay. A trial consists of drawing a ball at random from the bag, noting its color and replacing it back in the bag. A game is played by performing 10 trials. Okay, great. So this will be binomial because is with replacement. So one way is it makes life easier if we use binomial. Okay, the player receives 50 cents for every blue ball drawn in a game. He receives nothing if the balls of other colors are drawn. Okay, great. So this case here, what we need to understand is this. Please do not see it as 4 red. Okay, I think the crux of it is if you see it as 4 red, so you see it as 4 red, 5 blue, and then 6 green, then you'll be in problem, right? So all I need to see is 5 blue balls versus how many? 10 non-blue. Okay, that is the idea there. Then essentially these are 15 balls in total, right? So again, 10 trials. So you have 10 trials here. A game is played by performing 10 trials in all. Player receive 50 cents for every blue ball drawn. You receive nothing if 50 cents. Exactly 3 will mean that how many balls you're drawing. You take 3 divided by 0.5. That will be 6, right? So 6 blue balls. Okay, that's the idea there. Shouldn't be an issue. So I'm gonna let x be the number of blue balls drawn out of 10 balls, 10 trials, right? Okay, that's 1. So x binomial, then what we get is actually the trial is 10. Then what we get here is 5 out of 15. Okay, the success rate for each binomial ball is 5 out 15. That's about it. So first one will imply that the required probability is that probability where exactly $3, right? Will mean that exactly x is 6 balls. Okay, that's about it. $3 will be 6 balls. Key in calculator. So what you do is just second distribution, go to binomial PDF. Probability density function trial is 10. Success rate will be 5 out of 15. X value will be 6, right? Then you just paste it. Oh, what am I doing? Sorry, this is distribution, binomial PDF. 10, 0.0569. So this is like 0.0569. So this will be 0.0569 3SF. Okay, that's 1. Then we look at part 2. Oh, this is A. Typo here. More than 250. More than 250 will mean that 250, how many balls are there? 250 will correspond to 250 divided by 50 cents. That will be 5 balls. Okay, so the required probability is more than 250 will mean that probability of x more than 5 balls. Okay, so you do not want to have at least 250. 5 balls will be exactly 250, so you want $3 and above. So this case here, just remember, take 1 minus px. This is discrete, so meaning to say it's a bit confusing because this is discrete. It's the same as sequence and series. So what you do is 5, 6, and then this is 4. If you want anything more than 5, so you minus off this chunk here. Okay, so everything here, so it's just 1 minus p at most 5. That is the confusing part. Usually students have a problem. So once we are done with this, CDF will be at most 5. Okay, so what you do is just 1 minus of binomial distribution, CDF. Then the trial will just be 10. This is 5015 and x value is 5. So for CDF, we usually just put at most, so that will be 0.0765 6. So 0.070765 6. That will be okay. So that's one. Okay, great. So find also the amount where the player is most likely to receive. So actually, this is modal class mode. Okay, you want to find the most frequent. That is pretty okay. So what you do is just go to your calculator similarly. So now we want to find the mode, means the most probable class which will happen, right? So what you do is you just go to the y function here. We want to find out. So you go to distribution. You go to normal PDF. Then the trials, maybe we put say normal trials 10. Then the success rate is 5 out of okay, great. Just distribution. PDF 15, then 5 out of 15, and I'll put this as a variable x. Okay, so I just want to find from the classes here from 0 to 15 what is the most probable class that I'll get. Though you look at this case here, 5, 21%, you have 21% rate. Okay, so just write from GC, this is the table that you got. So this case here with x, px, right? Px equals to x. So we have got 4, 5, okay, 4, 5, and 6. 0. This is 19%, I believe. 4, 8, 5 will be 0.21. For 3, 6 will be 0.1786. Okay, so hence the modal class is 5. Okay, 5 will mean that so most likely amount is 50 cents each ball, right? I key in wrongly. This is not 15, this is 10 actually. So I just second table here, so I think I'll just clear up. Yeah, there you go. So this is 3, 19.51. okay, just complete this. So I key in wrongly, I put 15 trial instead of 10. So from here we can see this is the most likely one because this is 26%. This is the highest, right? So this case there, the modal class is 3 lah, 3 balls, 3 blue balls. Okay, so the most likely the amount a player most likely to receive is $1.50. Okay, cause so you take 3 times 50 cents, right? There you go. That's part B. Part C is an interesting one. So at the start of a tournament, each player plays the above game once. A player who earn more than K proceed to the next circle. I think just see it as more than how many blue balls. So take K divided by 50 cents balls. Okay, it's easier to do it in terms of the number of balls, right? Because that's what we have been doing. Move to the next round. Find the least value case such as a random sample of 10 players. Probably that. So this is like binomial. We did another binomial because now the success rate will be PK more than this value here. So we'll look at this case here. Okay, rewrite this. So for C, let Y be the number of players proceed to the next round. out of 10 players. Okay, so meaning out of 10 players, we want to know, okay, so chances of it going to the next round, this case here, will be actually based on the previous binomial distribution, which is px. It has to score more than k, so meaning to say k divided by 50 cents. Okay, so this is it. So this is like binomial within another binomial. It's usually something which students have problem identifying, but this case here is hard to see, I understand, but what we want is actually find the probability that all the 10 players proceed to the next round is less than 0.1. Probability that all the 10 players, so py equals to 10, meaning to say y all 10 proceed to the next round is less than 0.1. Okay, so this probability is hard to see, but I can change this to a number of blue balls instead. So if this is like, say, this is like px, at least the minimum blue ball here, so I could just put this as 1 minus discrete, remember, b here. Okay, so this is the b that I want to find. So once we can find this b, we know that this b is actually equals to k 0.5, not an issue, okay, because it's discrete, number of blue balls there. So we can just write this as y binomial 10. Okay, because your calculator CDF always it always 1 minus of the value there. So I'm going to just put this as such. Okay, then from here, I could just use my calculator already. So usually what I'll say is it's always good, it's a habit of mine to just put the 0.1 to the other side. Okay, so then I'll just key this in the calculator and try and make sense of what it is. Okay, now this one is a slightly confusing if you are not sure what you're doing. Py equals to 0 is a PDF, so second distribution, I'm going to use binomial PDF, then after which the trial is actually 10. Okay, now the p value here is the one which is the tricky one. It's actually under 1 minus, this is the p value, CDF, second distribution, binomial, CDF. And this case here, x is 10 balls, is it? 10, yeah, there you go. 10, comma. You have to know the syntax, which is 5 out of 15, then comma x. Okay, then this will be value of 10. After which I minus off 0.1. Then I go to second table and I just scroll down which is the value which I need. So once I key it in, I realize that you see this value here. So from GC, I know that this diagram here, we have got P y equals to 10 minus of 0.1. Oh, okay, then I will just put this as the B value here. I know that the B value, this would be 1, 2, and 3. Then this is 0.233. Then this is negative 0.071, negative 0.1. Okay, there you go. So this case here, I need this to be negative because there's a negative here. So this will be my answer. Okay, so the minimum value of B equals to 2. Hence, the least value of K is equals to, if it's 2 blue balls, that will be 2 times 0.5, 50 cents, 1. Okay, so that's how we do this question here proficiently. If you have any questions at all, please let us know and I'll see you in the next question.